Thank you very much for the kind introduction. So yes, this is a joint work with Gavin sitting in third row. We are both working for these it's fine. We are working for this DICE ITA program. That is a consortium between the UK and the US, and this is sort of side work from the mainstream. By the way, I'm recording this talk because at some point it might be ready for be distributed on YouTube. But for any questions, I will just remove from the recording, so don't worry. So the contribution of this paper is in the direction of supporting human analysts in assessing the uncertainty in sources and information when using sound ontology and uncertainty robust automated reasoning. And we are going to make strong assumptions about what means intelligence analysis. So we are considering a very specific view on intelligence analysis, especially intelligence analysis as a sort of example of using scientific inquiry. And even when we are talking about scientific inquiry, we are considering a very skewed view of what scientific inquiry is. So we are very much Popperian. So we are considering scientific inquiry more in the context of conjecture and refutation of hypotheses and try to figure out what can be tentatively accepted as true, as no scientific theories are ultimately true according to Popper. But so far, enough for the caveat on our work. The plus on focusing on this from this perspective is that we can actually use scientific inquiry as a proxy problem for intelligence analysis, and we don't need to go into classified information or unclassified information. That is going to be much easier. So to exemplify what we can do right now, let's consider a scientific inquiry question, which might be, does MMR vaccination cause autism? And that is a very fine question, and like any other human being in the world, if you're facing this question, you probably just go on Google, and you might end up with a gentleman tweeting, well, that's true because there is a paper saying that. By the way, this is a synthetic tweet, but trust me, there are very similar tweets. I just didn't want to put real identities here. So if you are a little committed, then you might look at this magnificent paper, and you might actually read it. And you actually can see that this paper from Wakefield is actually talking about behavioral symptoms associated by parents of 12 children to MMR vaccination. So they look at 12 children, and the parents of those children reported that after the MMR vaccination inoculation, the children start having behavioral symptoms associated to autism. And then if you are really committed, you might put this paper into Google Scholar and look at which are the papers that are linking to this paper, and you end up finding this paper from a few years after that shows that there is no statistical association between MMR vaccination and behavioral symptoms over 537,000 children on a study done by a university in the Netherlands. So what can we do right now to collect this piece of information and reason about these different sources of information? Can be done using argumentation theory, and argumentation theory is a branch of artificial intelligence that tries to reason about uncertainty in a qualitative ways, and in particular using arguments. And arguments that we can create using semi-structured logic. So like in this format where we can want to start building an argument, for instance, from witness testimony, because we might have some source of information telling us something. And this scheme that has been derived by legal scholars. I appreciate that if you want to adopt in other contexts, you might need to change it a little, but this is just out of the shelf from the literature. You can say, you can link the witness to what he's telling you, and you might have some assumption that the witness is telling the truth, this kind of things. But the most important thing here is not just the argument itself, that is kind of in conjunction with the concept of conjecture in Popperian scientific inquiry, but also the notion of critical question. I try to strengthen your reasoning, because they want to try to minimize your cognition biases, your confirmation biases. So this is linked to the concept of refutation in Popperian scientific inquiry. And those were already built together because legal scholars like ways to attack each other's arguments, so that is part of their work. So one argument might be from witness testimony, the other one might be, for instance, from correlation to cause. So you might want, if you want to prove something, you might want to say that whether there is a cause for this one, and perhaps having a positive correlation between A and B is a starting point. Here you can see that arguments not necessarily need to be sound from a statistical point of view. This is a defeasible conclusion, that just having positive correlation might bring to causation. You should not read as a mandatory implication. So if we look at our example before, we have that we have a piece of information coming from Twitter here on the top left. And this is a sort of witness saying that MMR vaccination causes autism might be plausibly taken as true. Here we have that this comes from the Wakefield paper. So MMR vaccination causes autism can be the conclusion of a correlation to cause. That starts from a correlation between MMR vaccination and autism, and this comes from the fact that the parents of 12 children said that there is a positive correlation. And this piece of information can be mapped, is essentially in conflict with the fact that the other paper I show that there is no positive correlation between pieces of information. So what we can do is not just represent those arguments, but actually mapping out in this kind of graphical representation where these round boxes, empty boxes, represents rule of inference. These black boxes represent conflicts, and the square boxes represent information, essentially. Right, so great. What we can do now is try to do a little of logic in order to understand what we can fuse of this piece of information all together in order to make a complete picture out of it. And for doing that, we can just rely on many approaches present in the literature. I just choose my favorite one, just because it has the word simple logic inside. And essentially, you have a logical language, and you have atoms in this language with the notion of complement. So complement of beta, if beta and is equal to alpha, complement of beta is not alpha. You have the concept of rule. Premises linked in a conjunction implies a conclusion. And you have a logical knowledge base is just a set of literals and a set of simple rules. Which brings us to the fact that if we flatten all this graph here into propositions, so this box here becomes the proposition alpha, this box here becomes the proposition beta. This link now can become the rule beta implies alpha. And then you can move from this graphical representation into a symbolic representation. Now, what else we can do? We can have a notion of consequence, and the notion of consequence tells us that if we have at least one rule and we have all the premises in the rule, then we can have also the conclusion, and that is essentially an application of the modus ponens. And this brings us to the possibility to create arguments in this formal notion. So an argument is a set of propositions and rules in this support that links on this conclusion alpha. So here we have that the simplest argument here is beta that is given, and beta implies alpha is giving us the conclusion alpha that is summarized in this bit here. Then we have here that there are two arguments. There is the argument A3 that is epsilon implies delta, and then a little more elaborate epsilon implies delta implies gamma that is giving us A4. And the last thing that we need to do is take in consideration this notion of conflicts. So there are two ways we can do it. The first one is when we have that the conclusion of an argument is in negation of the premise of another argument, and that is defined as undercut. And the other one is when the two conclusions of two arguments are conflicting each other, and that is called rebuttal. And in our simple example, we have that this argument here, that is A1, is mutually conflicting with this argument here. So we have that A1 rebuts A3 and A3 rebuts A1. But this one is also a sub-argument of a bigger argument, right? But for the bigger argument, what is the conflict here is in the premise, which means that A1 undercuts this bigger argument. So fine. Now we transform from just graphs into logic base into arguments and conflicts. What we can do now is to try to figure out what are arguments that are acceptable together in order to give us a complete view of the situation. And for doing that, we can use Dung's 1995 that is telling us that when you have arguments and the notion of conflict, you have essentially an abstract argumentation framework. And once you have this one, it means that you have a new graph where you just abstract from everything that is up here. You just look at what are the arguments and what are the conflicts, because everything that you are going to do in terms of computation is going to be based only on the notion of argument and the notion of conflict. So the fact that there is a mutual conflict between A1 and A3 is captured by this cycle here, and the fact that A1 undercuts A4 is this directed edge here. And once you have this representation, you can compute extensions that are set of arguments that are collectively acceptable according to some principles and survive all the conflict together. And for this representation, I just consider one semantics, one way to compute this set of arguments. There are many. And this one is clearly satisfied the principle of conflict freeness. You don't want to have conflict pieces of information fused together. You want admissible in the sense that you want to defend against the attacks, and you want maximality in the sense you don't want a set to be a subset, an extension to be a subset of another, a bigger one. And in this case, you have, trust me, two preferred extensions. One is looking at the fact that the conclusion of those extensions will be the conclusion of the paper from Wakefield, and the fact that there is a correlation, a causation between MMR vaccination and notice, and the fact that there is this Twitter person, and the other one would be instead that the Madsen paper conclusion, but also the Twitter, because there is no explicit conflict between this paper and the other. And this is a potential problem that we want to address now. So what we proposed in the paper, and that I invite you all to read, is a very fun paper, is how we can go beyond what we can do right now. This is what we can do right now if you're looking from a argumentation perspective. So first of all, we should include trust in the source of information, but also in a way that we can use both from a human perspective and also from a machinery perspective, which means that the trust must be context dependent, in the sense that, well, Twitter might be a great source of information if you are interested in the latest Kardashian news, but might not be the greatest source of information for scientific inquiry. Trust needs to be expressed through an ordinary scale, because apparently humans are better at reasoning with labels rather than with numbers, but at the same time we want to be able to reason automatically with this type of labels, so at least an ordinal scale is necessary. And these two were already the subject of another inquiry that we did last year. And in this paper, we introduced these additional two desiderata. The first one is that not only the trust should be expressed in our ordinal scale, but we want also to express uncertainty on the piece of information that we receive from the source of information on an ordinal scale in the same way. And the last one is we want to collapse all together this one in this framework, in these argumentative frameworks of conjectures and refutations. So in terms of ordinal scale, what we were considering is the traditional Admiralty code, which is absolutely fine. because if you start saying that A is greater than B, A is greater than C, etc., you have ordinals, essentially. What we did in the past was creating an ontology, so definition of concepts and relationship between concepts that has the key aspects here in trust, that links a query with a source with a trust description. So the query is the question whether MMR vaccinations are causing autism or not. The source might be Twitter, and the trust might be one of the Admiralty Code elements, like completely reliable, usually reliable, etc., etc. Fine. What we extended now is, in addition to trust, query, source, and trust descriptor, we now have that this source of information is telling us something. So there is an illocution between this source of information and some piece of information we are receiving. And this illocution, this act of somebody telling us something, is linked also to an uncertainty description of the information that we are receiving. So somebody is telling us that something is happening with a certain level of uncertainty. And this, once again, is expressed on an ordinary scale. Fine. Now, regarding the fourth requirement, the desideratum, what we have now is a much more rich way to express piece of information, because we now can say that the source of information on Twitter cannot be judged internally the truth, so is the trust associated with that one. Whether there is some uncertainty associated with the piece of information that is telling us. We can also add now new schemes that are reasoning about this piece of information, probably through other level of uncertainty, and we can compute automatically a fusion of uncertainty on top of it. But at the same end, what we had before, for instance, in terms of inconsistency, now might become a probabilistic inconsistency type of reasoning. But the framework remains the same. We just added probabilities inside. So what we can do now is probabilistic inferences and conflict. So now it's no longer correlation to cause, it's probabilistic correlation to cause. We have probabilistic inconsistencies. We can have parametric fusion of uncertainty, so the fact that we have some level of trust and some uncertainty on the piece of information we received, we can be fused together, and we have explicit fusion of uncertainty. We can have recursive illocutionary act, so now we have that the paper refers to the fact that some parents tell us about that. So we have a different level of granularity that we can express. So to conclude, we expand on previous work to complete the ontology picture. Great. We have now the possibility to have arguments about uncertainty assessment of information, and arguments that represent fused uncertainty information with also a recursive illocutionary act expressed as argument themselves. And if you're interested in further information, there are many on the website. Thank you very much for your attention.